Okay, so 3-2 is about graphing quadratics. Okay, so our goal here is to identify key features of a quadratic function given an equation and the graphs of the given an equation in the graph of the function. Okay, so we're going to actually be given all three of the equations in different forms and graph it. Before we do that, we want to just review some of these ideas. Can anybody raise their hand and tell me what an x-intercept is? Jeannie? That's the x-axis, but what's an x-intercept? Yes.
Oh, whatever crosses.
Yes, where it crosses the x-axis. Mm-hmm. Okay, it's where our graph crosses the x-axis. The y value is 0. On the x-axis, the y value is always 0. So then the y-intercept is where your graph will cross the y-axis. That means then that the x values is 0 there as well. So on the y-axis, the x value is 0. Any questions over that? The vertex of a quadratic function is the highest point for your parabola or the lowest point of your parabola. It's both. It can be either one, depending on which way it's facing, and I'll show you. Is the maximum or the minimum point of the parabola. So if I have a basic sketch of a graph here, this is my x-axis, this is my y-axis. And if I have my parabola like this, the vertex would be here. And this would be the minimum. It'd be the lowest point on the graph. We can also have a parabola facing a little differently. And if my parabola faces down, then that vertex is a maximum. Because it's the highest point my graph will go. Any questions over that? We're all good? Okay. The max and min is the vertex. Of the parabola. The vertex of a parabola. Okay, so now I've given you the graph of the function here, the factored form of that same function, standard form of that same function, and vertex form of the same function. We want to identify from the following forms of the quadratic equation. What can we identify? The goal here is to figure out what can I see using these different forms of the quadratic function. To do that, we want to look at the key features of my graph. Okay, so let's see. Here we're going to look for the x-intercepts first. Where it crosses the x-axis is right there. So our x-intercepts are going to be -1 and 3. And you would write those as an ordered pair. You would do -1 for the x value, and then on the x-axis, the y value is 0. And then you would have 3 for x and 0 for y. So those are your ordered pairs, your x-intercepts. Then we're going to look at our graph once again and find now the y-intercept, where it crosses the y-axis. So here's my y-axis, and it crosses right here at -3. So my y-intercept, the x value is always 0, and the y value in this case is at -3. Any questions over that? And then we want to identify the vertex. So I'm going to go here. Okay, remember it's an ordered pair, so we need an x value and a y value. The vertex, the x always goes first, and the x was 1. And the y value is next, and it was at -4. So remember, when you have an ordered pair, the x comes first, alphabetical order, x then y. Now, class, is that vertex the maximum point or the minimum point? Minimum. It's the lowest point for my graph. Any questions over that? Okay, so for B, C, and D, I want you guys to find all of those key features. Sebastian, what did you get for the y-intercepts?
0, 8.
X is 0 and y is at 8, +8. Elizabeth, what did you get for the vertex? Okay. -3 and -1. Okay, any questions over that? Oh, and Elizabeth, was that a maximum or minimum? It's a minimum value. Okay, let's try the next one. C. Alexis, what was the x-intercepts here? Okay. 1 and 0 and 5 and 0. Are we good? Didn't want to interrupt. Okay. Y-intercepts then. Elizabeth, what did you get for the y-intercepts? The y-intercept crosses where? That's the x-intercepts. I'm looking at the y-intercepts. Where's it across the y-axis? At what kind of 5? We're on C? Negative 5. 0 for x and negative 5. Okay, then we need the vertex. Bianca, what's the vertex? For C. Okay, the x value is 3 and the y value is 4. Very good. And was that a maximum or a minimum? It was a maximum. That is the highest point we have. Any questions over that? Okay, then our next one. Aaron, what did you get for the x-intercepts?
I didn't do this one.
Where does it cross the x-axis? Uh-huh.
And then -3.
Very good. So you'd have negative 1 and 0, and then negative 3 and 0. Hiba, what'd you get for the y-intercepts? 6. It crosses the x or y-axis, sorry, at 6. Way up here. And so my x value is 0 and my y value is 6. Okay, then we need the vertex. Alyssa, what's the vertex? What was it? 0, 6. Oh, that was the y-intercepts. I'm asking for the vertex. -2 and -2. And is that a maximum or a minimum? Any questions over that? Okay, now we want to see where our 3 forms of the equation, how they relate to my key features, my x-intercepts, my y-intercepts, and my vertex. If you look at those 3 equations that I've given you for each one of these, what can I see based on the factored form, the standard form, and the vertex? Everyone write something down for those 3 questions right here. What do you identify in the graph given a factored form? What key features can you identify? Everybody write something down. Okay, did anyone figure out what we could identify on the graph given the factored form? Nobody found anything they could identify. Key features in factored form. Sebastian?
I don't know. Well, yes, I said like the coordinates.
Of what?
Points.
Of which points?
Like the y values.
The y values?
Yeah, because like you know how you plug in like the 1 and
Yeah, the equations, you can always plug in a number and get something out in any equation. But I'm saying if you just look at the factored form, what can you get of our key features? Yeah. The x-intercepts. If you notice here on my factored form for letter, I think this is C, my x-intercepts were 1 and 5, and my factored form is x minus 1, x minus 5. If you look over here, my x-intercepts were -1, -3, and then in factored form I have x plus 1, x plus 3. Same over here. Factored form was x plus 4, x plus 2. X-intercepts were -4, -2. Is it exactly what's in factored form? Is it exactly what's in factored form? How are they different? The signs are the opposite. So that's what we can write down. What do you identify in the graph given factored form? You can identify the x-intercepts. Given factored form. You have to, though, change their signs. Any questions over that? So in factored form, you can see clearly identify the x-intercepts just by seeing what numbers are being added or subtracted to the x and then change their sign. Any questions over that? Okay, how about anything else? How about standard form? Was there anything we could identify in standard form? Y-intercept. And how did you find the y-intercept? Okay. So here, my standard form, I have -5. And then my y-intercept was -5. Here, my y-intercept was at 6. In standard form, there's the 6. The y-intercept was 6. Okay. So you can identify the y-intercept given standard form. This is what we call a constant. It's the number without a variable. That's what a constant is. Number by itself. Okay? What can you identify the graph given standard form? You can identify the y-intercept given standard form. It is the constant. The number without a variable. In the equation. Any questions over that? Do we need to change the signs on those at all? No, it's the same signs. Okay. Anyone want to take a wild guess as to what we can identify in vertex form? Yes. Yes. Very good. Okay, so I can identify the vertex given vertex form. But if you can see, the number inside the parentheses is going to change signs. So here inside the parentheses, it's -3, and then the vertex is a +3. The number outside the parentheses is the same sign. Okay. The number inside the parentheses that is with the x value is going to be the x value of your vertex. The number outside the parentheses is the y value. And that occurs every single time. Okay, the number inside the parentheses is a +2, so the x value is going to be -2. The number outside the parentheses is -2, so the y value is going to be -2. Any questions over that? Okay, so let's write that one down. The x value is in the parentheses and is the opposite sign. The y value is outside the parentheses. Okay, did you guys notice anything else? Yes.
It said that if you split up the parabola in the middle, that both each side equals each other.
Okay, they're symmetrical. Very good. Anyone notice anything different about the equations? Do we know how we can identify if it's going to have a maximum versus a minimum? Mm-hmm.
Maximums are upside down.
Yes, but looking at the equations, how can I tell from the equation that it's going to be upside down? The negative where? In front. Okay, if you notice, these all have negatives right in front. And that meant my parabola is going to face upside down, therefore it have a maximum value instead of a minimum value. Okay, so if there's a negative in front of each equation, then the parabola will have a maximum value. Yes. What are you asking? Oh, instead of an if. Thank you. Appreciate that. Okay, there's one other thing we have to identify. How are these equations and this graph in D different from the rest of them? Okay, it has a 2 in front where none of the others had a 2, like a GCF of 2 here. 2 in the front of the x squared, 2 in front of the parentheses squared. What did it do to the graph? What can you notice is the difference between, say, D and B and A? It's narrow. It's a thinner parabola. Okay, so if you have a number, an integer in front, it's going to make your parabola thinner. So like here, here, and here. Okay, so if there is an integer in front of the equations, then the probability was thinner. Okay, so the next page, they're going to want us to graph. Graph the following function given the 3 different forms of the function. So the first thing we want to do is identify the y-intercepts. Using the factored form. Okay, so when you look at the factored form and identify, not the y-intercepts, what intercepts do I need to identify? The x-intercepts. The x-intercepts using the factored form. Okay, so if I go back up here and just double check what I have to do, you can identify the x-intercepts given factor form. You have to change the signs though. So here I'm going to have 5, and it should be a -5 because I need to change the signs, and a +1 and 0. Change the signs. Any questions over that? So I'm going to go where x is 5, sorry, -5, and y is 0, which is right here. Then I'm going to go where x is 1, and y is 0, which is right there. I'm going to graph those 2 points. Then I'm going to find the y-intercepts. Using standard form. I'm going to go right back up to here. And to identify the y-intercepts, it's the constant, the number without the variable in the equation. So I go back here. The constant is that -5. So the y-intercept is 0 for x and -5 for y. So I'm going to go where x is 0 and y is -5, which is right here. Finally, I'm going to identify the vertex. Identify the vertex using the vertex form. And back up here, we said you can identify the vertex given the vertex form. The x value is in parentheses and is the opposite sign. And the y value is the opposite, is outside the parentheses. So here I have the 2. So it's -2. And I have the 9, it's -9. With the x value, I change the sign. With the y value, I do not change the sign. This is the same sign. So here I'm going to graph where x is -2 and y is -9. And then I just graph the parabola. Now let's review. You're going to make it a U shape. So don't try and make it like a V. Make it more curved. And make yours prettier than mine. It's harder for me to work it out on here. Any questions? Okay, you guys do the next one in your pairs. Make sure you guys can do that. Okay, so the x-intercepts here will be -2, 0, and +4 and 0. So 4 and -2. The y-intercept is 0 for x and -8 for y, because the x is always 0 on the y-axis. Then your vertex is -1 made positive, change the sign, and then -9. Stays the same. So I go where x is 1 and y is -9, which is right here. Since I have symmetry, I can also graph that point on the other side. I know that if I fold my parabola along the vertex, it's going to be the same on both sides. And then that's my parabola. Any questions over that? Okay, so now I'm going to be given the graph, and I have to find the equations for G and H. So we're going to start with the factors. Okay, so that's at 4 and 2. So I have f of x equals, now I don't know if I have something in front of it, so I'm going to leave a little blank there just to see what number's in front there. I do know, though, I need to change the sign, so it should be -2. And I need to change the 4 as well to -4. My ordered pairs were 2 and 0 for my x-intercepts and 4 and 0. So when I plug them in back into the factored form, it needs to have the signs changed. Any questions over that? Now, if I look at my graph for G, I can see that it's thinner than my graph for H. Okay, that should tell me that my graph is going to have a number in front of it, something that goes here. This is what we call an A value. We'll get more into it. The A value is the GCF, basically, of your function. The number that you factored out and put in front. Okay. In order to find that, the A value, so steps 2, find the A value. And A equals, kind of like the slope to the right 1. If I move to the right 1, how far up did I have to move to get to the next point? It's always right 1. And how far up did I move? And up how many? So A will equal 1. How far up did I move to get to that first point? 2. So A equals 2. Yes.
Where were you coming from?
So I started at the vertex. And I moved to the right 1. It's always to the right 1. And then how far up did I have to move to get to the next point? 2. So my A value is 2. Any questions over that? Let's look over here. If I'm at my vertex, I move to the right 1. How far up did I have to move? Get to that next point. 1. So it's always to the right 1 and up how many is what you're looking for. Okay, standard form, we just have to multiply everything out. So we start with our box. That's how we multiply binomials. And I have x minus 2 here, and then the x minus 4 here. I'm going to multiply it out. X times x is x squared. X times negative 2 is negative 2x. X times negative 4 is negative 4x. And negative 2 times negative 4 is negative 8. Not negative. What is wrong with that? Positive. A negative times a negative is a positive. Okay. Okay, we can't forget the 2 that goes in front. We still need that. And then we have x squared. We're going to combine our like terms that should be in the middle. Negative 2 and negative 4, they are the same sign, so I'm going to add them and get negative 6x and then a positive 8. But I'm not done because I still have that 2 on the outside. So now I have to distribute that 2 back in. So I'm going to get f of x equals 2 times x squared is 2x squared. 2 times negative 6 is negative 12x. And 2 times 8 is 16. Any questions over that? Yes.
Why did you say it was negative? Oh,
Are we good?
yeah.
Okay. Any other questions? Okay, vertex form. We need to identify the vertex, which is right here. The vertex is 3 and negative 2. Now, vertex form looks like this. We know that the 3 is the h value and the negative 2 is the k value. So we said that the x value goes inside the parentheses and then the y value is outside the parentheses. I already have that a value from way up here. So we're going to have f of x equals, my a was 2. Then I have the x minus, it's a positive 3, so make sure you have a negative 3 inside those parentheses, squared. And then the negative 2 stays the same. So that's vertex form. Any questions over that? We're all good? Okay, your homework is the next 2 pages in your packet.